Hey there, students. This is Mrs. Visconti again, and we're working on some multiplication today. Today we want to work with our patterns in zeros, making sure that when we multiply, we add the right amount of zeros to our answer. So our first problem here is 6 times 3. Because we know our multiplication tables, we know that 6 times 3 is 18. Now in class, I've been telling you to lock that product in a box because it will not change as you go down. 6 times 3 will be 18. 6 times 3 will also be 18. And 6 times 3 will also be 18. And as you can see, I'm getting that from the beginning of this factor and this single factor alone. 6 times 3 is 18 all the way down. Our next step then is to look at the zeros because we multiplied by not just 6, but 6 tens. We also have to add our zeros because we are multiplying in the tens. For this one here, I have 2 zeros because I'm multiplying 6 tens and 3 tens. So I add 2 zeros, and if I count from my end, I add my comma between my thousands place and my hundreds place. Now don't let this problem trick you. We are multiplying 6 times 3, but we are multiplying 3 hundreds. So that means we have 2 zeros. So the answer is actually going to be the same. By counting the zeros and following the pattern here, we know that anytime we multiply the digits here, we just take our zeros and simply add them on to the end. All right, let's talk about our area model multiplication that we've been working with. Here we have a single digit 4 times a double digit 37. Inside 37, we have a 30 plus a 7. So we are going to create an area model. Our larger box will be 30, and our smaller box will be the ones, that is 7. We're going to add those two together to create 37. We take our single factor and we add it along the side. Now because we know rectangles, we know that both sides across from each other are equal, same as the top and bottom. Now I am ready to multiply. So my first multiplication problem is going to be 4 times 30 for this area. And our next one will be 7 times 4 in this area. So we, again, like we did on the last page, we know that it's going to be 4 times 3. 4 times 3 is 12. I have 1 0, so I put my 0 in the ones place. For this second problem, remember that we are going to be adding the two products together for each rectangular area. For this area here, 7 times 4 is 28. Now I simply add those two together, the 8 in my ones place, a 4 in my tens place, and a 1 in my hundreds place. So 4 times 37 equals 148. Now what do you do if you have a single factor multiplied by a double digit number, but that double digit has no ones? You can do this two ways. First, you can draw, like I did over there, an area model showing our 60 and our 0 because there are no ones. Our single factor multiplies on the side. Because we know our rectangles, we know that each side is the same. 3 times 60 gives us the equation for this area, and 0 times 3 gives us the equation for that area. 3 times 6 we already know is 18, and we bring down that 0, put it in the ones place. 0 times 3 is 0 because anything times 0 is 0. 180 plus 0 gives us 180. Another way that we can show this area with a 0 in the ones place is we draw our tens squares. How many tens are inside of 60? There are 6 tens. So we have a single box of tens, another box, another box, another, another. And what is the single factor that we're multiplying? They are all going to be multiplied by 3. 3 times 10 is 30. And we know that that answer is going to be the same all the way down. 3 times 10 is 30. 3 times 10 is 30. 3 times 10 is 30. All the way down. I now have 6 groups of 30. I'm going to go ahead and add this. Students, you may recognize this is called repeated addition, when we repeatedly add the same number over and over again. Now I can just simply count it by 3. 3, 6, 9, 12, 15, 18. And I have a 0 in my ones place because we are counting by 30s. My answers are the same, and those are the 2 separate methods for creating an area model. Students, I hope you practiced tonight. You do have a quiz tomorrow, and I know you will do great. See you in class.